This episode is sponsored by Meter, the company building better networks from the ground up. Meter delivers a full-stack networking solution, wired, wireless, and cellular, all in one integrated system. From design and deployment to management and support, Meter takes care of it all so your business can stay fast, secure, and connected. Thanks to Meter for sponsoring. Go to meter.com/fierce network to book a demo now. That's meter.com/fierce network.
Network security is more fragile than you might think. Even though it feels like there's some kind of data breach every other day, it can and might get a lot worse. So let's talk about why. I'm Diana Gooverts, and this is the 5-9. When we talk about network security, there are two things you need to know. First, identity and access management are key. Keeping data safe is all about vetting who has access to what data. And second, encryption currently underpins a lot of today's internet security landscape. But both of these critical components are currently facing new challenges. So today, we are going to explore how and why AI agents and quantum computing could break modern network security, what role telecom network operators have in stopping these threats, and why everyone needs to start thinking about these problems now. So, with me today are Palo Alto's SVP for Network Security, Rich Campagna, F5 VP of AI and Engineering Guru, Jimmy White, and Fierce Network Research's own Mitch Wagner. So, guys, thank you so much for being here. And let's go ahead and dive right in with a baseline. What have been the biggest network security challenges over the past 5 years? And where are things starting to trend now?
If I take that question, I answer it at kind of a high level, from a high level view. I think there's really two big things that have happened in cybersecurity over the last 5 years, and these two things probably will continue to happen into the future as well. And that's not meant to scare people, but I think they're just kind of enduring trends that we have to make a part of our daily lives in cybersecurity. First one is, of course, the attack landscape continues to evolve. Right, attackers have gotten their hand. I mean, they use the same tools that we use, right? That even, in fact, many of the tools that that cybersecurity professionals in the industry as a whole have developed, to help, protect and test defenses inside of the organization. The bad guys use those same tools. So that, what we've seen is that the attack landscape continues to accelerate. So, if I were to look across our customer base about a year ago, across the many tens of billions of threats we stop every single day. About a year ago, there was just over 2 million, what we call new and unique, some sort of novel attacks on a typical day. And fast forward a year to today, and there's about 9 million. So we've grown from 2 million to 9 million new and unique attacks every single day, which tells us that attackers are getting much more sophisticated. And at the same time, their time from initial infiltration into a network to exfiltration of data or whatever the end game is has shrunk from about 48 hours just a couple of years ago to now minutes, right? So they're getting more sophisticated and faster, and that's largely due to things like automation, AI, other types of tools that we're, of course, using in our businesses as well. So that's trend number one. Attackers are getting better. They're not getting smarter, but they're just getting better because there's better tools. But the second thing is on us as an industry. It's on the enterprises and organizations using tools. It's on telecom providers that are kind of either using these tools on their networks, and it's on vendors like us. And that is that complexity has been perhaps the biggest bane to cybersecurity and to achieving cybersecurity outcomes. I think every time there's a new trend, AI, of course, being the current one out there, the industry responds with a whole bunch of new point tools. They don't talk to the prior tools. It's a net new infrastructure project to deploy. It's a whole new set of skills and expertise. So, on one hand, I'll give some credit to the attackers for getting more sophisticated and faster. On the other hand, I'll take some points away from us as the defense community as a whole for making things so complex that it's hard to achieve the outcomes that we need.
For me, from memory, the biggest problem that really gripped the world were a couple of things. One, ransomware. That was a huge thing that went on for a long time. It started off by just causing massive disruption, locking up people's devices, etc., and of course demanding ransom being paid. Secondly, then that moved to after the fact, extortion, exfilling data from networks. So that was the first big one that really, took maybe 2-3 years to get a handle on for industry. I also remember supply chain crises, like SolarWinds, etc. That was another big one that rumbled on for a while and had different manifestations. And then I think really, over the last 2 to 3 years, it started moving into AI space, which is now I think the biggest thing besides post-quantum that is currently in the, collective zeitgeist of security concerns.
I'm going to throw in there one more, which is that the rapidly changing geopolitical climate since last year. Companies formerly or countries formerly thought of as allies are now being viewed as potential antagonists. We've yet to see how that will play out in the cybersecurity space.
I want to dig into the AI element. I understand Gen AI introduces a whole new set of risks, and agentic AI could very well nuke things entirely. They are similar, but not the same. So can you talk for a minute about the difference between the two technologies and explain why exactly these kinds of threats are so scary?
First of all, we're seeing good old-fashioned phishing evolve, where pretty soon we will be receiving our last semi-literate email from a Nigerian prince. These days, AI is enabling phishing to be far more targeted and customized to the individual user. Spear phishing on an industrial scale, you might say. And then in the area of agentic AI, until now, to a large extent, security has been focused on the model of the user, the individual person accessing the network. You want to make sure that person has the right credentials. Now you've got all these agents running around that sort of act like human users, but do things on behalf of human users. It's very difficult to tell the good agents from the bad agents because they're very often doing the same thing.
Yeah, I guess Gen AI, 2-3 years ago was the new kid on the block, and everyone was experimenting with it, and it was novel and interesting and captured the world's imagination. And it took quite a while for enterprise to figure out how to use this thing in a meaningful way, to develop applications on top of it, etc. And for the most part, it was used as a kind of question answer type device where you would just ask it, questions about the world to create content based on that information, and then introducing new information like RAG information from different data stores and then asking questions across that. But the key difference or the key threat back then was non-existent unless you asked it a question. So unless you asked it a question, it was just sitting there burning through GPU runtimes, and it didn't cause any harm. Then when you asked it a question, two things would happen. One, the fear of DLP information going out from your network to that model provider, and that information potentially being logged or persisted, and then potentially stolen from those vendors. So kind of like a supply chain attack. And then the answers coming back, was it introducing misinformation or vulgar information or toxic information into your industry, or just incorrect information that somebody put into a place to cause you to do something or take an action that wasn't supposed to happen. When you move that to agentic, the whole landscape changes. So I guess the first thing is agentic. Its timeline to become, through POC into production is dramatically expedited because the comfort level is there now with Gen AI. So people are used to AI in their daily work lives, and agentic is now super interesting, and it can actually have much more meaningful impact because it has the ability to use tools. But the main difference is that agentic is autonomous and can be running 24/7, 365, does not require you to ask it a question to kick off a chain of events. And indeed, that autonomous activity can actually lead to massively bad consequences because you're not monitoring it all the time. You're not aware of what it's doing. You're not aware of what tools it's using. And it can do a whole bunch of other things that Gen AI just can't do. And so that's the big difference. It's always running, it's always doing things, and you're not aware of what it's doing. And it has tools to take the actions into the real and virtual space. So just since the holidays, we've had Claude Code become massively used and ubiquitous across engineers around the world. And then since then, that's like old news already. We had Claude Bot, a week ago, that got renamed twice in the space of a week, to Moltbot to OpenCloud right now. And so that you can run from WhatsApp, from Telegram. You don't even have to be near a computer. You can ask it to do tasks. It can connect to your Gmail, your Outlook, your Git repositories. And so these things are running on people's laptops. They're running in VPSs. They're running all over the world. People can actually code from the plane now, right? So I took a flight from Seattle to London last week. I was using Telegram with a CloudBot hosted in VPS. It had access to tools. That is the scenario we're living with today. And so even in the last month, things have moved on at light speed.
Well, let me start by saying that some of these tools are just awesome, right? I mean, they're transforming the way that we work, transforming industries. Organizations are, have the potential to, dramatically improve their competitiveness and their top line. The ability to dramatically improve their bottom line and their profitability. So, I mean, there's, in the 25-ish, 26 years that I've been doing this is like the most direct connected kind of big technology trend to the top and bottom line of a business that I think we've encountered, and it's being adopted faster than ever. So my view is that AI is much more good than scary, but like every other new technology, there's a set of risks that need to be mitigated. That's it. This is like the job of cybersecurity professionals, and it has been for decades now. Is there's new risks that are coming because of a change in the business, and the result of that change is that you have to look at things in a slightly different way.
So I'm hearing that action, memory, spontaneous decision making are all wild advancements, but also huge risks. So I want to follow up on specifically on that agentic angle. If agents are operating autonomously all the time, we're not really paying attention. They're just kind of doing what they do in the background. We've given them a task. They're just kind of doing in the background. How are you able to tell friend from foe on the network, right? There are going to be tons of them. How do you differentiate between a malicious agent and a agent that's actually doing what it's supposed to do?
Because it hasn't settled yet, the patterns are changing quicker than we can decipher what the patterns are. It's going to be a mixture of behavior, technology, monitoring, and then the ability to keep threat intel up to date at an alarming pace. So, one of the best examples I can give is that when you authorize something like CloudBot, you're not creating a service token or a delicate access. You're actually authenticating it yourself. And so it believes it's you doing the communication or using the tool or the API, etc. And so a behavioral aspect of that, an example would be, if you can do something good much faster than you traditionally did it, it's probably an agent doing that. If you're doing something bad, it just has to be a one-off. So it's really hard to apply behavior to negative tasks. It's really easy to apply to positive tasks. It's just speed and volume that you use as the metrics. So we're going to have to figure out, what the non-negotiable, you can't do that as an agent type scenarios are, and a whole new identity paradigm. So most of the current authentication authorization systems aren't fit for purpose when it comes to agentic use cases, unfortunately.
Well, I think this is a classic cybersecurity problem. That you could ask me that same question about actual employees of an organization, and I think the same set of concerns apply. The only difference is the employees aren't working 24/7 like you described the agents doing, right? So, I think it's no different. I think of this as your invisible workforce, right? You have these set of folks now. You haven't hired them. They don't have a key card, but they can do many of the same things that employees can do. And fundamentally, I think the same types of controls need to apply, but maybe in a different way, right? You treat that invisible workforce as if it has an identity. Just like employees of a large organization have a certain sets of permissions inside of that organization. You put those same constraints and controls on those permissions. What data can they access? What apps can they use? What actions can they take in those applications? And then you have to continuously monitor, right? And just like an employee on an organization's network today, I come into my office in the morning and I start taking a set of actions. And if I start deviating from my normal behavior and doing something that it perhaps seems quite risky, then hopefully there's some monitoring system in place that's going to identify that and pause or at least have somebody investigate that risky behavior. And so this is the core of what organizations have been doing for years now with their zero trust strategies. And this is no different. It's just a new set of identities now that we have to put those same controls on. And perhaps the integration points by which we can take those controls are slightly different, but it's the same kind of fundamental concept. It's an agent has an identity, just like an employee or a partner or whatever else has an identity. And we build a set of rules and controls around those.
So I don't want to get too hung up on AI, because obviously AI is the headline grabber, but it is not the only new technology shaking up the security landscape. Quantum computing and other quantum technologies are also poised to introduce new challenges. So I want to talk about that for a second. What exactly do the emerging threats in this space look like? And when and how can and should enterprises prepare for them?
You have this concept called Q Day. That is the day that quantum cryptography and quantum computing evolves to the point that all existing encryption is broken. And when is this going to happen? I've seen there are estimates out there that it could, there's a greater than 50% probability it will happen by 2035, which is 9 years away. And what we're seeing now already is harvest now, decrypt later attacks, because there is a lot of information, proprietary information out there that will still be valuable in 9 years. Trade secrets, long-term contracts, privacy information. So attackers are just grabbing all this encrypted information and sticking it in a data warehouse somewhere with the expectation that they will be able to decrypt it in 9 years or whenever Q Day arrives. So what's happening now is there is regulatory efforts in place in both the United States and Europe requiring post-quantum cryptography to be able to encrypt information in a manner that will even resist quantum decryption. Part of this is really fascinating, and part of it is kind of boring. It's like we've all been protected by 50-foot walls now, and somebody's about to invent the 75-foot ladder. So now we have to raise up our walls by 25 feet. Oh, wow, big deal. And it does. I'm old enough to remember Y2K, when, again, it was just scrambling around to get us all back to where we started.
Yeah, so the biggest threat, I think, in post-quantum, the two biggest ones are, one, any data that's exfilled between now and then. So whatever encryption level is used to store at rest, if it's not ready for PQC, then it needs to be a really big concern, because that data will be decrypted once quantum arrives. And so how do you prevent this? The biggest thing, I guess, is to catalog all current encryption techniques in your company and prepare for mappings to the PQC era. So we know we have NIST standards being developed, and those standards help us effectively map from current to FIPS, 203, 204. They're the standards that folks need to be moving to. But step one, get a catalog of all your current encryption, particularly at rest. And then secondly, create that mapping from your catalog to the appropriate FIPS new standard. And so that's the best you can do right now, but it's going to become a really, really big problem, and the clock is ticking.
Is it just a matter of, I know you're talking about moving from one NIST standard to the other. I had a conversation actually with NIST around identity tokens recently, but one of the things they mentioned is that encryption keys could just get longer. That's part of the solution. It feels, I don't want to say inadequate, because that sounds like I know of a better solution, and I don't. But are there other elements to it besides just longer encryption keys?
I mean, yeah, there are. So I think it'll cause a rethink on how folks store the information, where they store them. So if you combine PQC with AI is causing a massive duplication of information all over the world. So people are moving it into data stores, into models themselves. All this information is duplicating around the world. And so when you pair that with PQC, the propensity for that information to go into places it shouldn't go is expedited. And so what we need to do is, one, figure out, as we said, those different encryption standards, but two, where data goes and where's appropriate for it to live. And then, of course, we haven't even mentioned yet sovereign data requirements that have now entered into the public zeitgeist with the geopolitical events of recent months. And so we're probably going to see data need to be recatalogued. So where is it allowed to live? Where can it transit to? And then when it's in those locations, what are the appropriate encryption standards that are region-based? And each region will set their own standards. And so you're going to have data that's encrypted in different standards in different regions. Some will be partial data, some will be whole data. And so it actually creates a much more complex environment for the PQC era when it does arrive.
Encryption is interesting, also geeky, but interesting because we have relied on the same fundamental technology for encryption since the 1970s, if you can believe. Like, I can't think of anything else in any other realm of technology where we've been using the same stuff for 50 years, which kudos to the small number of individuals that invented those technologies. Moving to new forms of crypto is not without precedent. Like, as I mentioned before, we've made our crypto stronger over the years. And so over, the 26 years I've been doing this, we've made our key links in cryptography, continuously stronger, and that has helped us to stay safe against, attackers using the types of computers that we have available to us today. What has to happen over the next couple of years before we get to this sufficiently powerful quantum computer is that we need to upgrade assets, starting with network infrastructure, to support what's known as post-quantum ciphers, and these are cryptographic algorithms that are simultaneously safe against attack from a classic computer and an attack from a quantum computer. And I probably made that sound easy again, Diana, but the challenge with this one, the asterisk next to it, is that where we have to make that upgrade is on every single asset, that can communicate digitally, right? Every laptop, every IoT device, every network infrastructure component, every application. And so this is it's a relatively simple change, even though quantum seems kind of daunting and scary to people because they don't understand the quantum physics. It's a relatively simple change. We just need to support some new cryptographic algorithms in all the things that we do. What's challenging is that, in a given organization, there may be hundreds of thousands or more, when you take into account all the different devices, network infrastructure components, application. And so this is a really big and time-consuming process. And so even if, most experts are thinking like 3 to 5 year time horizon before we get to this, but organizations that aren't starting today are going to really struggle to meet that time horizon just based on the amount of work that has to be done, between now and then.
I'm going to be following where that goes, but our audience is primarily telecom and tech professionals. So I want to kind of turn the lens in that direction for a minute. What role do telecom operators have in helping prevent or mitigate AI and quantum threats? Where are they responsible? Where can they be a critical partner?
So the global economy depends on fossil fuels and telecom. It's essential. Telecom depends on fiber, Ethernet, and encryption. So the fact of encryption being broken pretty soon is a big deal. So telcos have the responsibility to make sure that their networks are secure and that the information they transport is secure. But that is also an opportunity. We are seeing, in general, telcos are starting to diversify to become security service providers for the enterprises and the consumers that they connect. And this is part of that service, making their customers quantum safe.
The world today relies on them 100%. They are critical infrastructure globally. And so that makes them the biggest facilitator, but also the biggest target. And so I guess where I would start first is they are going to have a great requirement to look after their own infrastructure, to make sure that they are PQC compliant, and to offer services that facilitate others to be PQC compliant. When you couple that then with that sovereignty aspect that's come in as a big topic for 2026, that further exasperates the need for these telcos to provide the infrastructure to facilitate information traveling between regions and with new rules in place for that data. And then also to facilitate greater loads in region, right? So we're going to have a lot more traffic inside existing regions, and different data flows that are non-traditional. So if you look at the traffic loads across the world, those patterns will change in the next few months as the regional aspects come into play. So I think, long story short, them being prepared for PQC enables everybody else to be prepared for it. And then understanding how that will all change with sovereignty coming in. It's something that we'll look to those companies to take the lead on.
Honestly, I think that telecom operators can have an incredibly strategic role. I mean, if you look at these technologies, I mean, we're talking about AI and quantum, but really any technology, there's only one common thing across all technologies, is that in order for them to work, they need to communicate. And the way they communicate is on a network. And who controls the network? The telecom operators, right? And so I think that, there is a critically important role that these operators can play, provided they position themselves properly for some of these technology changes that are happening. But that's it. Like, the foundation of all of it is the network. If you want to see whether a device is communicating to an application in a quantum safe way, where do you look? The easiest place to look is on the network, right? And if you have AI agents, kind of running around, these millions of agents you described before, all over the place, taking actions they shouldn't be taking, and creating a real mess of an organization. Where's the right control point? Once again, it's in the network, right? So to me, this is like, it's like obvious, and the only question is, how much of a role do these operators want to play in terms of developing the right capabilities to to help mitigate these threats. But I think that it's a huge business opportunity right now, in fact, for telecom operators, and in the very near future with regards to AI, and in the very near future with regards to quantum. And on quantum in particular, the key thing I think the operators need to do right now is start building, regardless of whether they want to kind of build a business, think in a net revenue generating business around that. They need to start thinking about how they're going to upgrade their networks to quantum safe encryption technologies today, because we're starting to hear a lot of demand from enterprises for this, and that will translate into a set of capabilities that are required of the network providers that they have in those organizations. So I would for that, regardless of the net new business opportunity, they need to start today.
All right. Well, thank you all so much. I think that's a great place to end things today. So thank you so much to all of our guests for being here today, and to our listeners and viewers, wherever you are listening or watching, make sure you like and subscribe, and we will see you next time.